Hello and welcome to the dimensional analysis homework. I will be showing you exactly how to do this work and what I'm looking for when I'm grading your papers and putting the grades into the Skyward so that way it can boost it up to 100 and you can finally make the better grade that you so badly desire. Okay, so let's start this. With the first number we have 28,750.9. Okay, we have to write that in scientific notation. So the first thing we're going to do is make it a number that is between 1 and 10. So we move it 1, 2, 3, 4 times to make it 2.87509. And I didn't mention this yet on the paper here, but I want all your answers to be rounded to the nearest hundredth place. That is 2 decimal places to the right. And so if we do that, we get 2.87 rounds up to 8 again. And 2.88 is between 1 and 10 and therefore qualifies for scientific notation. We multiply it by 10 to an exponent, and that exponent is 1, 2, 3, 4. We moved it 4 times there, and it's going to be a positive 4 because we moved it to the left. Remember, if we move it to the right, then the integer will be negative. So that's what I want to see for the first one. For the second one, we have to write this in decimal notation. And remember that decimal notation is the actual value of the number. So this is the actual value of the number, but decimal notation is literally just the non-scientific notation of it, the number that you come up with when you punch all these numbers in the calculator. 1.8 times 10 to the negative 4th. And as you all know, it's 1.8 basically saying times 1 over 10 to the 4th. That's what it means when you do something when you have a negative integer. You're literally putting a dash over it and a 1. And so when we take 1.8 here, we have to move it to the left 4 times. 1, 2, put a 0, 3, put a 0, 4, put a 0, put our decimal point and the other 0 behind the decimal point, just so that way we can see that the decimal point's there. So we'll rewrite our answer here. Oh yeah, forgot, box all your answers. We're going to rewrite 0.00018. And that's how we write that in decimal notation. For the next one, it's the same ordeal. This one says 5 to the 6, but because it's positive, we're going to move the decimal place to the right. So we have 4.58. We have to move that 1, 2, 3, put a 0, 4, put a 0, 5, put a 0, and 6, put a 0. That's where the decimal point stops. And we end up getting 4,580,000 as our decimal notation. So we just write it over here, 4,580,000, and box that out. That becomes our decimal notation. Moving on up, it says use a calculator to calculate the 2. I'm going to go ahead and get it out here and write the whole thing in scientific notation. I got my little trusty graphic calculator. Let's clear that out. The number says 0.0042, so I'm going to put 0. Let focus. Come on. Focus, darn it! Oh well, that's as good as it gets, but 0.00442, and we're going to multiply that by 330,000. So 330,123. Oops, that's not it. 0, 1, 2, 3. And so we end up getting 1360. So on your paper, what I'm looking for is 1360, or 1386. That's what it says, 1386. Somewhere on your paper, just write it like this. And you want to write it in scientific notation. And obviously, this number is not between 1 and 10. So we have to move the decimal place until that makes it happen. 1, 2. 13.8, nope, not quite right there because it's greater than 10. 1.3, yes, that is greater than 1 and less than 10. So we get 1.3, and I said we're using 2 places to the right of the decimal, so 8 rounds up to 9, so 3.9 times, we moved it 1, 2, 3 to the left, so it's 10 to the positive 3, and box that out. That is your answer for that question. Okay, and then it says use a calculator to evaluate those numbers, and what that says right there is 3,600,000,000 times 23. So that's what we're gonna punch into the calculator here. So let's clear this out. 3,600,000,000. Yep, see 600. 1, 2, 3. 1, 2, 3 times 23. That equals that. Actually, this one already puts it in to a scientific notation. But what I want you to do is write the fact out that it is, in fact, 828 to the 10. So 8.28. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should have 8 zeros in front of that. And to write it in scientific notation, you would literally go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right back. And you get 8.28 times 10 to the 10th. Or let's see it over there. 8.28 times 10 to the 10th power. And if your calculator kind of erred, just go ahead and copy this. But ultimately, this is what, if you do the math all the way out, you get, what is this, comma 3, 3, 3. You get 82 billion 800 million. So that's what you should get. And then you move the decimal point 10 times to make this between 1 and 10 times 10 to the 10th power. So that's the answer I'm looking for that one. Okay, so over here it says write this in scientific notation, or actually this is supposed to say, oh yeah, write that in scientific notation. The question is this in scientific notation or not? And the answer is no, because 531.42 is not between 1 and 10, so we move it once. 53.142 is not between 1 and 10, so we still got to keep moving the decimal point. 5.3142 is. So let's write that in there. 5.3. 1 stays the same, and that's what we get. So we move the decimal place 2 times, but it's already saying right here 10 to the 5th power. So we just add on 2 more times. 10 to the 5th, move it once. 10 to the 6th, move it twice. 10 to the 7th, and that gets your answer. 5.31 times 10 to the 7th power. And y'all have to understand the reason why we have to continue breaking down this number right here is simply because this is not in scientific notation, because 531.42 is not between 1 and 10. So that first number is not written in scientific notation yet. And so that's how we remedy that situation. Okay, determine the number of seconds in August and September combined. Well, if we look at the month of August and September, let me get to my trusty calendar here. September is 30 days and August is 31 days. So, August, 31 days, September, 30 days. And so the first thing I want you guys to do is divide it into hours. So we take 30, or divide it into days. Hours actually, yes. 30 times 24, and that's how many hours it is. 31 times 24, that's how many hours is. And what that equals is, let's get that real quick. 31 times 24 equals that. This is 744 hours in that month. And then 30 times 24, I have a calculator, and that equals 720 hours per month. Now, how many minutes are in each month? So then what you simply do is multiply that by 60. So you take 720 times 60 equals this, and that equals times 60, that equals 4,300 and 200. And then you take 744 times 60, this one times 60 equals 44640. Okay, and that's how many minutes there are. And in each minute there's 60 seconds. So we multiply those by 60. And we get 44640 times 60 equals 2,678,400. So for the month of August, somewhere there, you have to put 2,678,400. And that's how many seconds are in the month of August. And then for the month of September, you simply take the number of minutes, which is right here, 43, it's right here, 43,200 times 60, because that's how many seconds there are. And what you get here is 2,592,000 seconds. So those are the amount of seconds in September and August. Now all we do is add those two things together. Plus 200, so we're going to take 2,592,000 and add it to 2,678,400 seconds. Our answer that we get is this: 5,270,400 seconds. Now, we have to write this in scientific notation because this is just too big of a number. So let's move our decimal point. 1, 2, 3, 4, 5, 52.7. That's not below 10 yet. 5.27 is. So we get our new answer over here should be 5.27. And we look at this over here. Yeah, sure, whatever. It makes sense. We don't have to round 7 up or down. Times 10 to the, we moved it 1, 2, 3, 4, 5, 6 times. I think I said 7 earlier, but this is the answer I'm looking for, because you moved the decimal place 6 times, and then that becomes your answer. Okay, and then the back side is very easy. It's just conversions. Over here it says, we're omitting number 8. So those of you watching this video know that number 8 is omitted. There's a bad typo on there, so that's what we're going to do. Okay, this one says 1750 milliliters to liters. So we write down what is known, 1750 milliliters over 1. And we have to multiply that by something to convert it. Well, ml is over here, so we know that our ml is going to be here, and we need to find our liters, so our liters are going to be up here. Okay? And how many milliliters are in 1 liter? There's 1,000 milliliters for every 1 liter. And so these cancel out. I want to remember how we said in class, these have to cancel out. So what you end up having is 1750 divided by 1,000. And that's how many liters you get. So let's punch that into the calculator. Clear that out. 1750 divided by 1,000. And you get 1.75. So your answer is 1.75 liters. Box that answer. There you go. The next one says 0.75 grams in the milligrams. So we're going to do 0.75 grams divided by 1. Our desire is milligrams over grams. Now, there are 1,000 milligrams in 1 gram. These grams cancel out. And so what you end up having is 0.75 times 1,000, and that's what it will equal your milligrams. So let's punch that into the calculator. 0.75 times 1,000 equals 750. Your answer is 750 milligrams. Bam, bam. Please excuse my terrible handwriting. Some of you, even the males, have wonderful handwriting, and that's awesome. Okay, 250 milligrams over 1 equals grams over milligrams. And remember, we always have to multiply. No, it's not equal, sorry. You multiply that by the cancellation on the bottom. So whatever is in your numerator right here, your denominator in your conversion has to be there as well. So now you just calculate how many milligrams in a gram. Well, there's 1,000 milligrams there, and there's out of per gram. These milligrams cancel out, and so what you end up getting is 250 divided by 1,000. Let's type that in. 250 divided by 1,000. And that's how many grams there are. 0.25 grams. So that equals 0.25 grams. Bam and bam. But remember, show your work here. Over here, it says 0.25 liters. So we go 0.25 liters, and we want to convert that into milliliters. Okay, so then we just have to simply put that over that and put that over liters. There's 1,000 milliliters per liter. The liters cancel out. So you end up getting 0.25 times 1,000. And that's what will equal that many milliliters. That's what will equal our milliliters. So let's punch that into our calculator. 0.25 times 1,000 equals 250. 250 milliliters is your answer. Two more. Here we go. 2,100 milliliters to liters. So let's draw that out. 2,100 milliliters. And I misrepresented that wrong, and I'm sorry. And over 1. And we want to convert it into liters. So liters over milliliters. How many milliliters are in 1 liter? If you check your chart once again, you get 1,000 milliliters per liter. These 2 milliliters cancel out, and you end up getting 2,100 divided by 1,000. So let's go ahead and type that into our calculator here. 2,100 divided by 1,000 equals that, 2.1. That equals 2.1 liters. Last problem for dimensional analysis homework is convert 500 milligrams into grams. So let's do 500 milligrams. Okay? And we multiply that by, we're trying to find grams, and since milligrams is up here, our conversion is over here. Milligrams. How many milligrams per gram? 1,000 milligrams per gram. These milligrams cancel out, so you end up getting 500 divided by 1,000, and that equals how many grams you have. Pop that in the calculator. 500 divided by 1,000, and what you get is 0.5. 0.5 grams. And that concludes the dimensional analysis homework. If you do everything accordingly, you do get all credit, and that boosts up your grade. And don't forget to turn these in a couple days, and I'll see you in class. Peace.